Now next we talk about Bernoulli's principle, which is almost the governing principle in aviation in terms of the aerofoil theory or anything. Generation of lift to in engine also it is there. Okay, so Bernoulli was a scientist who said that the static pressure of a fluid, that is a liquid or a gas, that decreases at points where the velocity of the fluid will increase, provided that no energy is added or taken away from the fluid. Okay, which means if there is a pressure decrement in a moving fluid, if the pressure decreases, then the velocity will increase, and if the pressure increases, then the velocity will decrease. Okay, so it is basically the fluctuation of pressure and velocity. If one decreases, then the other one will increase in a fluid that is moving. Now, how we can actually see this? We can see this through a venturi, which is almost a type of a pipe that whose area will first gradually decrease and then slowly the area will increase. Okay, so that is called a converging and diverging duct also. Okay, where the area first converges then diverges. Okay, so this is the venturi. You can see the area first decreases from A to B, and then from B to C the area then diverges. Okay, so when the area is normal, then you can see the velocity and the pressure is showing different diagrams, showing different indications in the diagram. Now when basically the area is narrow or constricted, that it is converging at this particular position, as the area is decreasing, so the pressure will be decreasing. Okay, and the velocity will increase. See, the velocity increased and the pressure has decreased. Now again, in the diverging section, the pressure and the area the velocity and the pressure will come back to its original value. Fine, what it was before in the initial section. So that basically talks about the Bernoulli's theorem. And if you actually see this particular section, if I draw for you over here, it will be clear to you. If I draw this type of a if I draw a venturi like this for you, then I think it will be clear to you that this area actually resembles the upper surface of an aerofoil, if you clearly see, which means that at this point, when the air comes and goes over the top of the surface, at this point pressure is decreased and velocity is increased, as we saw. Okay, so if pressure is decreased, which means a suction will be created, there will be low pressure which will pull the aerofoil up or which will generate the lift. Okay, so this is basically the theory behind the generation of lift or movement of any blade in a turbojet or turbine engine. Okay, all the blades which are one by one kept in the rotor or aligned or put in the compressor, they also rotate in one direction whenever the fluid flows through them like this. Okay, whenever the fluid flows through them like this, they also move in one particular direction altogether, and that creates the rotation of the blade. Okay, that creates the rotation of the blade or the shaft on which they are mounted. So it creates the rotation of that particular shaft. Fine, so that is all about the Bernoulli's theorem. Now let us just see 2 to 3 more things under Bernoulli's theorem. So in the white section, what will happen? The pressure will go down. Sorry, in the white section, in the expanding section, we can see, or in the diverging section, the pressure goes up. Means if area increases, pressure increases and velocity decreases. But if area decreases, then velocity decreases, velocity increases, and pressure will decrease. Fine. So over here there is a formula which is total pressure is equals to the static pressure and the dynamic pressure. That means that any movement that is taking place due to the motion of the fluid, it is basically having two types of pressure. One is the pressure due to the static, that is one is the pressure due to the body at rest or the fluid being at rest, and the other pressure is due to the dynamic pressure or the pressure due to the motion of the fluid. Fine.